Hey guys, and welcome back to another video. So firstly, I just want to thank you guys for tuning once more, and I appreciate all the support you guys are doing towards this channel. It's really helping my channel grow, and of course, thank you guys as always. Now, what's this video about? So in this one, I'm doing a partial walkthrough of the further pure maths paper, yeah, and this is the first paper. Now, the reason why it's partial, not complete, is because I just want to test the waters here and see if you guys actually want me to do this paper. If you guys want me to do the complete version of this paper, let me know and I'll go ahead and do it. But yeah, guys, other than that, I'm just going to jump straight into this paper, so I'll see you guys in a bit. So, figure 1 shows a sector OAB of a circle. Now, the circle has center O and radius 10. Now, this sector has an area of 25 and the angle is theta radians. Cool. They want us to find the value of theta, so this angle, plus the length of the arc, AB. So arc is here, A to B. Now, typically these kind of questions, guys, every time you're dealing with sectors, it's good to write down all the relevant formulas, yeah? So the first one we see straight from the beginning is the area of the sector, yeah? So the area of the sector is like this. It's A, which is area, equals half r squared theta, okay? And the length of the arc is the other one, which is L equals just r theta. Now all you gotta do, guys, is just update these values, yeah? So we know that the area is 25, so A is 25, and the radius r is 10. So this means for the first equation, we're gonna have 25 equals half times r squared, so half times 10 squared times theta. Whereas for the second one, it's just simply L equals 10 times theta. Cool. Now going to the first equation, yeah, we can just literally rearrange to find theta. So we got half times 10 squared. 10 squared is 100. Half of that is 50. And then we divide it across, we have 25 over 50. So we can say theta equals 25 over 50, which is just half. Now therefore, if you substitute half into the second equation, the length of the arc is just 10 times a half, which is 5. And that's it, guys. We got both results. Now, let's move on to the next one. Cool. So the equation here, which is 3x squared minus 5x plus 4 equals 0, and it has two roots, yeah? Alpha and beta. So what this means, guys, is that if these were just regular numbers like, I don't know, 2 and 3 or 1 and 4, etc., this means that if you factorize this, you get two solutions. The two solutions they use are roots, okay? Now, without solving this equation, form a quadratic equation with integer coefficients. In other words, keep it all in whole numbers, yeah? Your quadratic equation that has roots of these two quantities. Alright, cool. Now, let's take this step at a time, yeah? So on the first line, it tells us that this quadratic equation has these two roots. So what that means, yeah, and without solving this equation, we can say that if we somehow factorize this, yeah, if you work backwards, you would ask yourself, firstly, what two numbers do we need to multiply to get a 4? Okay, in this case, we need to use alpha and beta. Let's write this here. To get a 4, so to get your constancy, we need alpha times beta, yeah, so alpha beta. However, when you have like a quadratic equation where the value of a, the coefficient for an x squared is not 1, so in this case it's 3, you got to multiply one of these two values by 3. So it'll be 3 times alpha beta, and this is supposed to equal 4. So that's one equation. Now the second one we also need to find is usually the middle part, the beta. And we say, okay, if we got our two roots, if we add up these two roots, it should equal that. But because you got, again, 3 here, you got to multiply them. So we can say, all right, to get, in this case, minus 5, yeah, it's going to be 3 times your alpha plus beta, your two roots. And it'll give us minus 5. Now, from here, we can say that from both equations, alpha beta for the first one, if you divide it by 3, equals 4/3. And for the second one, alpha plus beta equals minus 5 over 3. We could solve this, and get individual results. That's cool too. But let's just leave it like this for a second here because we can solve this quite fast. Now, since we showed you how to do the first one, let's try the second one, guys, yeah? So it's literally the same equation, but the only difference is we need to form a quadratic equation. So let's call this quadratic equation, I'm going to change the letters, yeah? So I'll use capital letters. So capital AX squared plus capital BX plus C equals 0. Now we need to work out what A, B, and C is. And we know part of the solutions. We know that it has these two roots, yeah? And the first one had these two roots. So let's copy the idea, yeah? So using the same method, yeah, let's say, like just how we were able to find 4, let's say to get capital C now. So to get C, we just have to do, again, the first term, so it'll be capital A times your two roots. So our two roots are these two terms, so it'll be alpha plus 1 over 2 beta times beta plus 1 over 2 alpha. And again, this is supposed to give us a solution of C, yeah? Now, all you have to do is just expand the bracket here. So therefore, we're going to have, let's see, let's have a look. So alpha times beta is alpha beta. Alpha times 1 over 2 alpha. So that's alpha over 2 alpha. So basically, alphas cancel out. You got half. Next one, beta times 1 over 2 beta. That's just 1 over 2. And lastly, 1 over 2 beta times 1 over 2 alpha. That's actually 1 over 4 alpha beta. Cool. And that's supposed to equal C. Now the good thing here, guys, yeah, is that you don't actually need to, again, work out these terms individually. We can use the results from the first part. We know alpha beta equals 4/3, yeah? So let's replace this one of 4/3 and that one of 4/3. So now we have A bracket 4/3 plus, well, a half plus a half is 1 whole, plus, so 1 over 4 times that. So 1 over 4 times 4 over 3. And again, that all equals C. Now, what you could do, because it's a calculator test, you could put all of this in your calculator. And if you do that, you should get a result of 121 over 48, yeah? So take your time, guys. Put this in a calculator, see if you can get that result. Now you got this result, you can say, therefore, you're going to have A times that coefficient. So it'll be 121 over 48A, and that equals C. So we'll leave this one here. So we found a C so far. Now, let's try and find the second term. So just like how we found -5, let's find B. So we can say to get, let me go down a bit, to get B, using the same idea, previously when we found the second middle one, we had to add up the two roots and times against the first term 3. So in this case, we're going to add up these roots and times against A. So be, in this case, big A, and then we're going to add up the two roots. The two roots were alpha plus 1 over 2 beta, plus, and the other second root was beta plus 1 over 2 alpha. And that's supposed to equal B, guys. Now, what we could do, we can just rearrange this order, yeah? Because we know from the solutions that alpha plus beta is -5/3. So we can add this up. Alpha plus beta is -5/3. So we've got A bracket -5/3 plus. Now, for these two terms, what we can do, we can just combine them and make sure they have common denominators, yeah? So one has beta, one has alpha. What we can do, we can times up and down here by alpha, and times up and down here by beta, yeah? If you do that, you're going to have alpha over 2 alpha beta. So we know basically both of them would be over 2 alpha beta, yeah? The first one, this would be alpha. And the second term, this would be beta. Cool. And now all of this, again, is supposed to equal capital B. So guys, one thing to be careful here. Try not to mix up your betas and your B's, or if you're using little lowercase letters, try not to mix your little a with your alpha. Now, final part here, guys, yeah? So now we can update the results. So we've got -5/3. We know what alpha plus beta is. It's just, again, -5/3 in the top line. On the second line is 2 times alpha beta. Alpha beta, we said previously, is 4/3. So this would be 2 times 4/3. Cool. And that's going to equal B. Now, again, put all of this in your calculator. I'm not going to lie, guys. This is a lot of steps in it. So put this in your calculator, and what did I get? And I got -55/24. Don't worry if the answers are slightly different to the mark scheme, yeah, because the final result will be the same. I was going through this a couple times. Now, because that's -55/24, again, so that means the final solution for this part would be -55/24 times A, and that gives us our B. Finally, guys, now we can wrap this up here. So we found our C, we found our B. We're going to go ahead and update this quadratic equation now with our results. So just quick key reminder, yeah? Our C result was here. So C was 121/48A, and B was over here. That means our quadratic equation is now ax squared plus, well not plus, it won't be bx, it will be minus 55/24ax plus, and our C value we said was 121 over 48a. So plus 100 over 21 over 48a equals 0. Cool. Almost done, guys, yeah? So one final step. 2 steps, actually. So because they all have a's, you can just divide a across so that it disappears. And now, in the beginning of the question, this would usually be the end, yeah? But they said, without solving an equation, form a quadratic equation with integer coefficients. So in other words, you got to make sure that your final results are all whole numbers, yeah? Not fractions. Now, to make this into whole numbers, let's just clear the fraction, yeah? So let's times everything by, let's see, 48. Because we know this is like a factor of 48. So times in 48 through, you should get a final answer of 48, that's not 48x squared minus, well, 55 over 24 times 48 is 110. X plus the last one, 121 equals 0. And that's it, guys. We've done it. Alright, cool. Now, in triangle ABC, AB equals 12 and BC equals 9, yeah? And angle BAC equals 42 degrees. Cool. So let's just sketch this out for a second, yeah? So you got A, B, and C. So let's say A, B, C. AB is 12, BC is 9, angle BAC is 42. Alright? Now, A. Find in degrees to the nearest 0.1 degrees each of the two possible sizes of angle ABC. So we're talking about angle ABC. So we're talking about here. Okay. An easy way to find the value x, guys, is to firstly work out the value of the angle next to C, yeah? So let's just call this angle here y for the sake of it. Now, what I would do is that I would use either the sine or the cosine rule, because these are the rules that always work for triangles. Now the trick is, if you're working with 3 lengths, then you're using the cosine rule. If you don't, then you have to use the sine rule. So let's match up what we know, yeah? According to the sine rule, we match up length with angle. So we've got 9 over sine 42. That's one of them. Now we need to find something else. Well, we also have 12 over sine y. Okay, cool. So now all we have to do is pretty much rearrange to make sine y the subject. So another way you could do this is write it upside down. So we can have either sine 42 over 9 equals sine y over 12. This is easier because that way we could just multiply 12 across to get sine y. So multiplying 12 across, guys, yes, I'll do it here. We're going to now have 12 times sine 42 over 9, and that equals sine y. So go ahead and put this in your calculator, and oh yeah, make sure your calculator is set to degrees mode, yeah? The reason why is because in question 1, you probably had it set to radian mode. So you have to set it back, otherwise your answers look a bit funny. Now work this out, guys, and then when you get a result, sine inverse that answer, yeah? And that will give us a result for y. And when you do that, you should get a y result of 63.1 degrees to 1 decimal place. Okay? Now, another thing you also need to do is, let's have a look. Yeah, so because they want, two possible sides of angle ABC, we should also have 2 possible sides of angle Y, yeah? Because of the sine, rule, sine property, they'll either think that you get an obtuse angle or an acute angle, so they're not really clear. At the moment, we've got an angle less than 90, so this is acute. To get the obtuse version, you just got to take this away from 180. So let's just call this the first angle, yeah? To get the second angle, it's going to be 180 take away 63.1, and this should give us 116.9. So this is our second angle, our obtuse version. Now that we've got y, we can work out x. So let's do this. So therefore, to get x, guys, yeah, it's going to be, well, we know all angles in triangle add up to 180. So we can subtract 42 and one of these pairs. So let's subtract 42 and 63.1 from 180. If you do that, guys, that means the third angle will end up being 74.9. That would be your acute one. Now, if you use the other one, if you subtract the obtuse angle, so you got 42, 180 take away 42, take away 116.9. Your other tiny angle would be 21.1 degrees. And that's it, guys. You got your 2 pairs of angles. Now, for the last part, part B, it says find to 2 significant figures the smaller of the 2 possible areas of triangle ABC. So again, to do that, you just got to use an area of a triangle formula. So let's do it. Well, because your triangle isn't a right angle and you haven't got any, you don't know if this is a base or not, we should use the other area triangle formula, which is the half AB sine C rule. Okay, we just need to pick two lengths between an angle. So let's focus on X here. So we're gonna basically take this shape. These two will be our A's and B's, and this will be our C. We could say that the formula now is half times 12 times 9 sine and then X. Okay, well, if you want to pick the smaller area, you're going to pick the one that has a small angle. So using 21.1 for X, if you substitute that in, so just replace this with 21.1, you're now going to get an area of, if you do it carefully in your calculator, guys, roughly 19 centimeters squared to two significant figures. And that's it, that's really it for number 3.